In ancient times, people thought of planet Earth as the center of a universe they could not understand. Nightly, they gazed up at the sky, always with wonder, often in fear, and sometimes in worship. Nervously, they watched comets and meteors blaze their way across the heavens. The sun, they believed, was the great creator God of all there is, and the giver of life on Earth. People of many lands have worshipped the sun since at least 3,000 years ago, when the Egyptians chanted praise to their sun god, Ra.
Hail to you, Ra, who rises at dawn without failing. Your rays daily warm the land, yet they remain a mystery to all eyes. Fine gold does not match your splendor. In a brief day, you race a course of great distances. Then the day has passed when you go down. When you stir to rise at dawn, your brightness opens the eyes of the herds. When you set in the western mountain, they sleep as in the state of death.
When covered wagons were rolling westward across the American plains, the Sioux Indians danced and sang their praise to their sun god.
It was a bold step from worshiping the sun as a powerful god to measuring it through scientific eyes as a mammoth ball of energy that warms Earth with its heat and pushes back the night with its light. Circling their shepherd star, the sun, the planets also became the focus of scientific eyes, and like the sun, were looked upon as fallen gods. In the 1600s, the mathematician and astronomer Johann Kepler became the first to know the paths of the planets as they glide endlessly around the sun in their orbits. He found that a planet close to the sun moves faster than one more distant. Kepler was fascinated by this discovery and worked out a mathematical plan that assigned musical tones to each planet according to its distance from our local star, the sun. Here was the music of the spheres, imagined by the Greek philosophers of old. Today, Kepler's idea has been extended to the planets discovered since his time and turned into sound by a modern computer, although the planets do not actually play this mystical game of musical orbits. Kepler used the idea to show the order and harmony he supposed must exist in the universe. First, swift little Mercury, then Venus, Earth, Mars, Jupiter, Saturn, Uranus, Neptune, and Pluto.
Of these wandering stars, as the ancients called the planets, one is very special. It is the third planet, alone among the planets, a water-covered globe, Earth, which would be better named Sea.
planets were born out of a chaos of gas and dust. A giant disk wheeling about the infant sun 5 billion years ago. One, which came to be called Earth, began as a boiling, bubbling mass of molten rock. Over many ages, earthquakes ruptured its cooling crust, and volcanoes poured forth gases that became its atmosphere. And then the rains came, hissing and steaming off the hot surface rock, until eventually the new crust cooled enough to hold the rain in pools. The pools grew into ponds and lakes, which flowed as rivers into low-lying basins. The first oceans.
What were the early lives of the other planets like? What upheavals shaped their surfaces? Were they ever like Earth? Earth is a restless, changing planet. Beneath the crust, molten rock forces its way up from the mantle layer as lava. Long ago, lava flows also sculptured the surfaces of our moon, Mercury, Mars, and moons of the giant planets. Heat stored beneath a planet's crust changes the surface in another way, quakes. On Earth, about 20 enormous rafts of rock make up the crust. Heat pouring up from the mantle moves these rock plates around. Sometimes, as they grind against each other, Earth shivers in vibrations we call earthquakes. Ordinarily, we cannot hear earthquake waves, although we feel their effects. Scientists record earthquake sounds on a slow-moving tape of a tape recorder. When the tape is then speeded up several hundred times, we hear hours of earthquake vibrations in only a minute or so of tape time. These West Coast quakes were triggered by slipping and grinding of the San Andreas Fault in California and Mexico.
Of all the mysteries on our changing planet, the one that touches us most deeply is the creation of life. Our bodies contain atoms made billions of years ago in the fiery core of a supernova star. A drop of dew, a diamond, a butterfly, and all other life forms are made of the same matter as stars and planets. The earliest life forms we know of were bacteria and simple plant-like organisms that arose some 3.5 billion years ago. The dinosaurs are gone. Humans have replaced them as the dominant land animal. One important way human beings differ from all other living things is that we can ask questions. Questions about ourselves and questions about the other planets and the stars that lie invisibly beyond the known universe. We are finding answers by sending spacecraft across the eternally
12,
dark reaches
11,
of
10,
space.
9, ignition sequence starts. 6, 5, 4, 3, 2, 1, 0. Liftoff. We have a liftoff.
Our satellite probes, such as the Mariner spacecraft, which photographed Venus, Mercury, and Mars, send back to Earth coded information about the planets and the Sun. Satellites called IMP told us about violent eruptions of hot gases in the Sun's lower atmosphere. We learn about the planets, the sun, and other stars by studying their light and other energy. But light is only one small segment of the radiation stretched out along that wide energy band called the electromagnetic spectrum. We can think of this energy as waves, like electrical ripples.
In the gases of the sun or any other star, electrons jump around inside the atoms. As they do, they release energy. At the upper end of the electromagnetic spectrum is energy of short wavelength and very high frequency, gamma rays, X-rays, and ultraviolet rays. Next comes the band of energy we can see, with violet light at the high energy end, then down through blue, green, yellow, orange, and red at the low frequency end. Below the red, we can again no longer see the energy, but we feel the energy as heat when we move into the infrared. And at still lower frequencies and longer wavelengths is the energy of radio waves.